Okay, so this is section 5.2, and it's about proving trigonometric identities. And I know most people don't like that word proving. Um, this is the only type of proof that I like, or maybe one of two. They are not like geometry proofs. You're not listing out a bunch of theorems. You're really just working through some algebra. So we're going to start with example one, which is literally just an algebra proof. We're not going to list any of our justifications. We're just going to show our work. And that's how we're going to justify this. So we're given this equation. And we're going to show that that equals 2. So the first thing I want to do is I want to get rid of my denominators. Now, usually I just multiply everything by my denominators, but this one has an easier way. If I look at that numerator, x squared plus x squared minus 1, I know that that factors the difference of squares, so it factors into x minus 1, x plus 1. And hey, I've got the same numerator twice. And if you notice, each of those has a factor that's the same as the denominator, so they cancel, leaving me with x plus 1 minus x minus 1. And I did intentionally put parentheses there because now I'm going to distribute this minus. X plus 1 minus x plus 1 equals 2. X minus x equals 0, and I've got 1 plus 1 equals 2. First thing you learned in math, tree school. So that's kind of the concept of what we're doing. Now we are going to do this with trig functions, sine, cosine, tangent. And we're going to be using all of our identities that we learned in 5.1. I don't think there's any new identities today. There'll be some new ones in 5.3 and 5.4. All of the ones that you need are on that identities sheet in your math Bible. So we're going to start with example 2 now. And this is going to use trig. We're going to go through a few different techniques for proving identities. So technique is use a side, pick it, and work with that one. Technique 2 is switch everything to sines and cosines. And I'm going to show you, I'm not actually switching this side. Right, I want to do that in a different color. But I'm going to show you what it is so I know when I get close. So I'm going to actually go back to this original here. But when I get here, I know we can just swap it. And my left side, tangent is sine x over cosine x. Don't forget the x's. Cotangent is cosine x over sine x. So important here, I need a common denominator, which is going to be cosine x times sine x. Oh, hey, look, that's what that's going to work out to be. If I wrote that as 1, that's what that would work out to be. And to get this, I must multiply by some form of a clever name for 1. If I want cosine x sine x for my denominator, that's the wrong one. I must multiply the right one by cosine x over cosine x, and the left one by sine x over sine x. So sine x times sine x is sine squared. Cosine x times cosine x is cosine squared. So again, all I did here was multiply each term by 1. I now have a common denominator, which means I can make them a single fraction. Our most basic Pythagorean identity, sine squared plus cosine squared of x equals 1, or cosine squared x plus sine squared x. So I end up with this, and I'll swap the order. I can multiply in either order, so I can swap the order to match what I had here. Finally, this is, I can split it up. 1 over cosine is secant. 1 over sine is cosecant. And there we have proven this. This section, work on your algebra skills a lot. One of the biggest skills that helps you on things like MAP tests and SATs is your algebra skills. And really any college entrance exam, I guess not an entrance exam, but a placement exam that you'd have to take for a college math class if you need to take any more after this. These skills, working these, really helps you score better. Or if you need to take a math class to get into grad school or an exam on math. So we have here, and this is kind of a matching problem. And option 1, so we don't know which one this equals. And I'm going to work it out by hand. But the easiest way to do this would be graph the original and then graph these two and see which ones are the same. I would do them one at a time if you don't have a color screen. If you have a color screen, you could just do all 3 of them at once and graph them and see what lines up. But it does say you have to confirm with a proof. So I'm just going to start by doing it with a proof. You could look at the calculator first if you think that's easier. I'm just going to start working on it though and going, I need a common denominator. I know I'm going to need a common denominator, so I'm just going to start there. And so I'm multiplying by a clever name for 1, that is the opposite denominator. Giving me secant x plus 1 times secant x minus 1. Those are conjugates. So that's secant squared x minus 1. Okay. So my numerators can combine. My denominator, secant squared minus 1. That identity, they're the same, but there's an identity that tells me that that's tangent squared x. My numerator, plus 1 minus 1 cancels out, so I'm left with 2 secant x. Tangent squared, 1 over tangent squared is cotangent squared. I'm guessing it's going to be number 1. Just a thought. Not quite there yet, but now I'm going to convert everything into sines and cosines. Cotangent is cosine x over sine x, which means I can cancel this with one of those, giving me 2 cosine x over sine squared. I'm trying to get to a cotangent, which means I need a cosine over sine. And I can do that by going cosine x over sine x times 1 over sine x to get me my sine squared. Cosine over sine equals cotangent times cosecant x. Oops. So that one we could find it by looking at the graphs, but then we're asked to prove it. Okay. Proving this identity. They often like to use t instead of x, which is fine. It's just a variable, or you could use theta. So I'm going to start here by getting a common denominator, or not getting a common denominator. So I know that 1 minus sine squared is cosine squared. So a little trick is I'm going to get this to 1 minus sine squared by multiplying by its conjugate. And again, I always do that top and bottom. So here I'm really only going to be working on the left side. Looking at that, my bottom needs a cosine, so I'm going to turn the 1 minus sine squared into a cosine squared. And then I can cancel that. Oh, hey, that's what I was trying to prove. It equals. That was example 4. Example 5. This one, they let you work on both sides. Generally, you try not to, but if you're stuck, you can work both sides. You can even cross multiply. The last one, sometimes I would do this and just go straight to cosine squared t equals 1 minus sine squared t and hey, that's an identity and you're done. So I encourage you to work one side first. That's the technical way to do it. But if you're stuck, cross multiply if that is going to work both, or just work both sides separately. So this one we have cotangent squared over 1 plus cosecant u. Well, this is u. This time they're using u for the variable. It's fine. Cotangent u over secant u minus tangent u. And I think what I'm going to do here is go 1 minus cosecant squared. No, cosecant squared minus 1. So instead of going straight to sines and cosines when I've got this denominator, I'm going to work that. And I'm going to factor this numerator. And I'm still going at that side. I need to put the u in. Because I have a difference of squares and I recognized it. And I know that that's going to cancel. With that. As soon as I recognize that, I'm just going to keep going before I forget about it. Now I'm going to start working the other side. And I'm going to multiply this by a conjugate. That's a trick that's really handy. Not secant squared, secant, just secant. I took a little more than I wanted. I need to remember to put the u's on here. I'm struggling with it with the u's. Usually do okay. So it's important that you don't just write tangent. You do have to write the variable. They do have to line up. Okay, so I'm left with cotangent u secant u. So I'm going to distribute while I do this. Plus secant u times tangent u, or cotangent u times tangent u is 1. The denominator, I've got a difference of squares, or conjugates, so I get secant squared u minus tangent squared u. So I know secant squared u is equal to 1 plus tangent squared u. And we're going to deal with cotangent secant. Now, cotangent is cosine x over sine x times secant is 1 over cosine x. And here I have a plus 1. Oh, I screwed this up. I screwed up the original equation. I was like, I felt like I was going to be off by a negative. And the truth is, I would be. That conjugate trick can be really useful if it was written in that form, but this isn't going to work out. I think it would have worked had I had a plus on the bottom. So the original should be this. So when I multiply, I get cotangent u secant u minus 1. Because cotangent times tangent, those are reciprocals, so they equal 1. Now, the same idea is going to apply. Cosine u over sine u times 1 over cosine u minus 1. The cosines are going to cancel here. And I'm going to get equals 1 over sine u minus 1, which is cosecant u minus 1. And so they're both equal. I could do the rest of this backwards, essentially multiply by 1 plus, yeah, cosecant u plus 1 and work all of this backwards to get back to the original if I wanted. But once I've got them equal on both sides, I'm good with that. Okay, there are some identities that we know in calculus that are kind of useful, and we're going to prove one of them. This one's going to look a little bit got higher powers here than you might be used to. Okay, so here's a little hint. I've got this 1 cosine x over here, so I got to have 1 left over there. So I'm going to start, I'm really just going to work this side over here. I'm going to take cosine to the 5th, and we have lots of identities for cosine squared. Okay, so I'm going to leave that 1 cosine. Now, this matches with what's underlined over here on my right. So I'm going to leave that one alone. I'm going to change the other 2 cosine squareds to 1 minus sine squared because I've got that version of the Pythagorean identity. So there's my cosine x tagged on the end. I'm going to FOIL out 1 minus sine squared. I'm going to do that before I distribute. It doesn't matter if you distribute the sine squared in first or FOIL that first. And when I do that, I get 2 minus sine squared x. No, not 2, 1. 1 times 1 is 1. Minus sine squared x minus sine squared x, which is 2 sine squared x. Plus negative sine squared times negative sine squared is sine to the 4th. Now I will distribute this sine squared to all 3 and get sine squared x minus 2. Sine squared times sine squared is sine to the 4th. Well, sine squared times sine to the 4th is sine to the 6th. And that's what I started with on my left side. Voila, I have finished it. And that is one of, there's kind of 6 different identities that are useful in calculus. If you take calculus, we'll introduce you to what they exactly are there. But you can look at your book at 459. I guess I can list them out. You'll occasionally prove things like this. So I kind of showed this one. That's real similar to the one we just showed. So you can't to the 4th. That's doing secant squared, and substituting. This one's a little different. This is one that we'll actually come across as a power reducing later, or not exactly this, but almost this, as or a double angle. So 2x goes to x. That is important. We'll come across ones like that. And this in a couple sections. This you would prove very similarly how I just proved the other one. And this final one that we just proved. And actually don't know if I've used this particular trig identity in calculus. Maybe at some point. Okay, that is section 5.2.